This is segment 10 of the Module 7 lecture, and in this segment we're going to discuss two examples where we calculate the confidence interval for the proportion. All right, so we're continuing with the example we introduced in the previous segment, where a study was conducted to assess the rate of uninsured individuals 18 years of age and older in the U.S. at the end of the first quarter of 2017. We mentioned that a sample of 500 individuals were selected at random. Each individual was asked if he or she had any type of insurance. We found that a total of 53 individuals said that they had some type of insurance. And the question is the true rate of uninsured individuals 18 years of age and older in the U.S. at the end of the first quarter of 2017 is the same as the rate of 10.9% reported at the end of the fourth quarter of 2016. All right, so now in here we want to see if these two rates are the same. We're going to calculate the confidence interval for the new set of data and see how that compares to the last rate of uninsured the last rate of uninsured that was reported. All right, so again, following the steps that I show you in the examples when we calculated the confidence interval for the population mean, in here we want to calculate the confidence interval for the population proportion. So the first step, gather the information, write it somewhere so that you don't make any mistakes as you use that information when you populate the equations for the confidence interval limits. So the sample size is 500. The observed number of successes is 53. The proportion of successes is 53 out of the 500 in the sample, and that's 0.106, and the confidence level is 0.95. So now the distribution to use in this case, well, we want to see if we can approximate the sampling distribution of the proportion with a normal distribution. So the way to do it, we multiply the sample size times the observed proportions, and we find that that product is 53, and then the sample size times the proportion of insured, that's 447. So the sampling distribution of the proportion can be approximated with a normal distribution because both of these numbers are bigger than 5. And that normal distribution will have a mean equal to the observed proportion, 0.106, and a standard deviation of calculated this way using the observed proportion, and that will be 0.013767. So now this is the new pieces of information that we have. So now the next part that we need is find the z-value that we're going to use in the confidence interval equation. So again, we use the confidence level. We find the alpha, well, the confidence level is 0.95. So alpha is 0.05. We divide that alpha value between the two tails of the distribution, and that's 0.025. So if you want to find the positive value of z, remember that table 4 gives you probabilities to the left. So we use the probability to the left of this z value, which is 0.95 plus 0.025, and that's 0.975. That gives you a value of 1.96. If you don't want to do that, then you simply use the probability in the lower tail, but in that case, you're going to find a z value of minus 1.96. What matters to us is the number, not the sign, because we're going to use that number in the equations of the confidence interval. So now here are the equations of the confidence interval. So we know that the observed proportion is 0.106. The z-value for alpha over 2 we found that to be 1.96. And here is the calculation of the standard deviation of the sampling distribution. Again, if you carry out these calculations, you find that the low limit of the confidence interval is 0.07902, and the upper limit is 0.13298. And of course, if you're interested in finding the margin of error, well, it's the product of the z-value times the estimate of the standard deviation of the sampling distribution, and that's 0.02698. All right, so now we have here the limits of the confidence interval, so the last step is to interpret that. So we said there is a 95% confidence level that the actual rate of uninsured individuals 18 years old and older in the US by the end of the first quarter is between, of the first quarter in 2017 is between 7.9% and 13.3%. Now, since the rate of 10.9% reported at the end of the fourth quarter of 2016 is within these two limits, then we say that there is no difference in the rate of uninsured between the fourth quarter of 2016 and the first quarter of 2017. So we say that they're not statistically different. All right, so if you were talking to these politicians, you can show this information and say, well, the rate of uninsured has not changed statistically from the fourth quarter of last year to the end of the first quarter of this year. So you cannot say that this program is failing. All right, that's an interesting example. I hope you find it interesting. I thought it was interesting. So let's look at another example. In this case, a Pew Research Center survey of online adults in the US included 1,074 Facebook users. Of the Facebook users, 935 are connected to friends from the past, such as high school or college classmates, while 419 of these Facebook users are connected to people they have never met in person. And here's a reference for that study if you're interested in looking more into it. And so what they're asking us is to construct a 95% confidence interval estimate for the population proportion of Facebook users who connected to friends in the past. And they are also asking us to construct a 95% confidence interval of estimate for the population proportion of Facebook users who are connected to people they have never met in person. All right, so we're going to follow the same procedure. Step 1, collect all the information. Here I added a step that we didn't do in the previous case, which is verify that this is a binomial experiment. So you can go through these steps and you see that we can say or assume in a reasonable manner that this is a binomial experiment, where success is the user is connected to people they have never met in person, or the other possibility of success is that they are connected to people that have met in the past. So the random variable counts the number of successes. And remember, we have two possibilities. The population of people that are connected to friends from the past, and those that are connected with people they have never met in person. So you can view either case as a binomial experiment. All right, so let's pull that information together. And now, because we're dealing with two problems simultaneously, I'm going to use X1 to indicate the proportion of individuals connected to friends from the past, and X2 not the proportion, but rather the number of individuals connected to friends of the past, and X2 the number of individuals connected to people they do not know. And so proportion 1 is 0.8706, and proportion 2 is 0.3901. The confidence level is 0.95 for both cases. So to determine if we can use the standard normal distribution for the first case as well as for the second case, we use multiply n times the proportion of success for those that connected to friends in the past, and the proportion of those not connected to friends in the past, and then for those that are connected to people that have never met in line. So you see in both cases, these products are much larger than 5, so we're justified in saying that the sampling distribution of the proportion for either case can be approximated with a normal distribution. All right, so let's find the z-value that we're going to use in the calculation of the confidence interval. Again, the confidence level is 0.95, alpha is 0.05. You divide the alpha between the two tails, we divide it by 2, so that's 0.025. And then using the probability to the left of the upper value of this z-value, 0.975, then you find on table 4 that the z-value is 1.96. All right, with that information, then we calculate the first confidence interval for the people that are connected to friends from the past. So we calculated the sample proportion as being 0.8706. We calculate the standard error or the standard deviation of the first proportion, which is given here, and that's 0.010023. And the margin of error is used the z-value times this standard error, and that's 0.0201. All right, so now that we have the margin of error, we can just calculate the confidence interval limits using the point estimate of the first proportion minus the margin of error for the first proportion for the low limit, and for the upper limit, we just add the margin of error to the observed proportion. So here are the values, the low and upper limits of the confidence interval. So by interpreting this confidence interval, we say that there is 95% confidence that the population proportion of Facebook users who connect to friends of the past is between 0.8509 and 0.8911, or we can say that it's between 85.1% and 89.1%. All right, so now we repeat the process, but now for the people that are connected to people that they do not know. So we have the calculated proportion of 0.3901, the standard error of the proportion, or the estimate of the standard deviation for the second proportion is we use the second sample proportion, and we find 0.01488. And to find the margin of error, we multiply this quantity times the z-value that we found, and that gives us 0.02917. So now with this margin of error, we can calculate the lower and upper limit for the second confidence interval. And the limits are 0.3608, the low limit, and the upper limit is 0.1492. So interpreting this confidence interval, we can say then that there is 95% confidence that the population proportion of Facebook users who are connected to people they have never met in person is between 0.3608 and 0.4192, or between 36.1 and 41.9%. All right, so this is the second example, and we're going to stop this section here. And I wanted to help you note that when I construct this confidence, or this statement of the confidence interval, I look at how the question was stated, and I use that same text and I put it here by just adding the level of confidence and then the values of the confidence interval. So hopefully that helps you construct this statement to interpret the confidence interval. All right, we'll stop here. In the next segment, we'll complete this module with a discussion of the minimum sample size.